Hello, everyone, and welcome to today's class. It's April 16th, and today we will talk about hose and loaders. Okay, so we will be talking about two machines today. Some updates, homework, the last homework, which is, I guess, homework number 7, has been posted. You don't have a very long time to do it. Actually, it has to be done before exam 2. It means you have 1 week almost to do that. There are only 4 questions, but they could be time consuming. So make sure you do have enough time to solve those problems. And what else? Yeah, quiz 5 grades were updated. As I mentioned before, some questions had to be manually graded, and I did that. So now, if you look at your grade for most of you guys, your score has been increased. Okay, so that's also about it. And B, start studying for exam 2, which is the last assignment of this course. And once you're done with exam 2, we might have some additional classes, but the materials that are covered there will not be asked. Okay, I may talk about cranes in those classes. So turn on your cameras and let's get started. Go ahead and share the screen with you all. Okay. Okay. Let me go to, yeah, hose. Okay, first, in the first part of the class, I will be talking about hose. Just give me 1 second. Let me pin this. Okay. Yeah. First of all, is there any difference between hoe and a backhoe? And the answer is no. The right word to choose is, the more uh, correct word to use is hose, but in the industry, people just call them backhoes. Okay. So when you look at the machine, the first thing that comes to your mind is that they really look like hydraulic excavators. Okay, so sometimes it could be difficult to tell them apart. But I have one slide that will tell you the differences between a hydraulic excavator and a hoe. But before that, let's take a look at different parts of a hoe. So as you can see, it has the bucket, there is a linkage. The linkage allows replacing the bucket with smaller or uh, larger ones, or also actually hose have a very versatile range of buckets. So depending on the operation, you could think of different buckets, and it actually provides a lot more versatile range of buckets compared with a hydraulic excavator. So on top of the linkage, there will be the stick. Okay, so this stick is actually to transfer the force to the bucket with the help of the hydraulic cylinder. Okay, so the attachments could help to mantle or dismantle or attach and detach different types of buckets. There are 3 hydraulic cylinders, as you can see. One is for the bucket, one is for the stick, and there is this one, which is also for the stick. Okay, so the operator is actually working with these cylinders plus the rotation, control, and also the bucket control. So you could think of 5 different types of motions that at least 5 that the operator is taking care of or is controlling. So we have the cabin, we have the engine, and other parts uh, that, as you can see in the picture. So just remember, we have versatile types of buckets, and they could be attached or detached very easily. The operator does not even have to get off the vehicle, off the equipment. So here you can see some main parts, major parts of the backhoe. As you can see, the bucket cylinder, the stick, the cylinders, the boom. So this is the stick, this is the boom, okay? So this is the stick, which is lighter green. The darker green is called the boom. And two cylinders control the boom. This cylinder controls the stick. This cylinder controls the bucket. That's how it works. So buckets, like I said, are available in different widths depending on the job requirements, and the penetration is controlled using these cylinders. Okay, so the maximum crowd force is developed when the stick cylinder operates perpendicular. Okay, so when this is perpendicular, you can exert the maximum force to the ground. But one beautiful thing about these machines is that they can have access to for a pretty good radius that is the combination of the length of the stick and the boom almost, okay, in when it is when it is horizontal, okay, so it can reach almost further spots. And sometimes it's good because the machine could be based, for example, next to water or next to uh, a hole, and do the operation for us. Okay, so these are the general explanations. One thing that is important is to know the difference between a backhoe and a hydraulic excavator. Okay, so looking at this, you can easily tell that it is a backhoe, but sometimes this part is detached and you only have you only have this part. So in that case, it looks like a hydraulic excavator. So how can you tell apart? How can you tell them apart? There are three main things that could help you to tell them apart. Number one is the size. The size of a backhoe is commonly or comparatively smaller than a hydraulic excavator. So remember that. Number two is the versatility. Backhoes come with versatile buckets, different types of buckets for different job requirements. But hydraulic excavators are a lot less versatile. And the third one is the motion. The motion of an excavator is, is wider. It could move for a wider range. As you can see, the entire cabin could be rotated. Okay, so it's better to call it rotation than motion. Okay, so the entire cabin could be rotated, but here, as you can see, the cabin is fixed. So this is one of the easiest way to tell them apart. If it can move, if the cabin moves, then it is an excavator. If it's fixed, then it is a hoe or a backhoe. So this is just a review of what I just said. It could be difficult to tell them apart, but they could be different in size. Excavators are larger and heavier. Backhoes are slightly smaller. Versatility, backhoes are more versatile. As you can see, different buckets could be attached to the back or to the rear or the front of the equipment, okay, based on the need. And actually, it's pretty easy to detach and attach them. I have a video that I'll show you today. Rotation. The rotation excavator operator can rotate more, okay? They can rotate for up to 200 degrees, while a backhoe does not have any rotation other than using the wheels to rotate, okay? So this is what I was talking about. The length of the summation of the boom length and the stick length shows us the radius of uh, how far the bucket can reach. Okay, obviously, It does not have the same productivity, or it cannot exert the same power when it is working in different depth or in different distances to the main cabin. Okay. And we have tables that will tell us when the machine, or at what spot the machine is more productive. So also the bucket could be filled for different amounts. Obviously, you are familiar with this concept, right? The softer is the soil, as you can see, for example, sandy clay or sand and gravel, you can fill the bucket for more than its volume. Okay, like this, like as you can see on the left. Okay, so you can fill it for up to 110%. Okay, but as you go down, you can see for harder soil, like for tough clay, you cannot fill the entire bucket. You can fill up to 80 or 90% of the bucket. So most of the time when we are solving problems, they will tell us the type of the soil, and that the purpose of that is to say what portion, what percentage of the bucket could be filled. Okay, so that determines the type of the soil, determines how much you can fill the bucket. Here I have a video if it works. Yes, it does. So as you can see, they could be used for different purposes. Let's watch this video. This is actually a hydraulic excavator. Okay, this is a hydraulic excavator, not a hoe, but I wanted you to see this type of bucket that you might not have seen before. Okay, so like I said, one main way, easy way to tell apart between a hoe and a hydraulic excavator is that a hydraulic excavator can rotate. And I have seen that people in the industry use them interchangeably sometimes by mistake. Okay. They say maybe pronouncing hydraulic excavator is more difficult than saying hoe. So most of the time they just use backhoe, even for hydraulic excavator, but that is not correct. Okay. So we also have hydraulic rams for digging in depth. As you can see, most of the time it should be perpendicular to the ground so that it can exert the maximum power. Okay, but sometimes you can't have that. The machine or the equipment has to stay in with some distance. Well, you can still do digging, but less power could be exerted to the ground, so it may take a longer time. Yeah, these are hydraulic rams. So let's take another look at some of the hoes. Basic operation of a hoe. Let me make sure I have my computer has voice. Oh yeah. Okay. That's sound. Okay.
Basic operation. To move your cat excavator forward, simultaneously press the two pedals forward. Alternatively, use your hands to move the two track levers forward. Bring them back to the neutral position to cease movement. Moving backwards requires the opposite motion, either pressing with the heel on the pedals or moving the levers towards yourself with your hands. Each lever or pedal is relayed to one track. Therefore, to turn right, press forward on the left lever or pedal. Similarly, to turn left, press forward on the right lever or pedal. To make the tracks rotate in a circle, simultaneously press forward on one lever and back on the other. The two joysticks are used to control the hydraulics of the excavator. Move the right joystick towards yourself to bring the boom up. Push the joystick forward to bring the boom back down. Moving the right-hand joystick to the left will scoop the bucket toward the cabin. While moving it to the right, we'll open and extend the bucket to release the material. With the left-hand joystick, you can rotate the excavator around its frame. Press left or right to move the excavator in the respective direction. Pulling the left-hand joystick towards yourself will fold the stick towards the excavator.
Yeah, so as you can see, the operator is using both hands and both feet to control. Well, that was an excavator, but it's pretty similar. The way you use an excavator is very similar to the way you use a hoe. Actually, using an excavator is a little more difficult because you're talking about rotation. Okay. All right. So hoes are good when you're doing excavation below the natural surface of the ground where the machine sits. Okay, so you can easily dig below the surface. Yeah, they could be, hoes could be also called as backhoes or even back shovels. Okay, same thing. When you need to excavate trenches or pits, they are superior to hydraulic excavators because they are smaller and so you could more easily use them. Because of the positive bucket control, they are superior to drag lines when the extended range is not required. So the main purpose of using drag lines is when you need an extended range, okay? So if extended range is required, drag line is obviously the first choice. If not, the positive bucket control makes it a lot more powerful than a drag lines bucket, okay? And wheel-mounted hydraulic hose are available with buckets for up to 1 cubic yard, okay? So as you can see, wheel-mounted hose buckets are not really big, are smaller than hydraulic excavators buckets. Okay, if you remember, I showed you when I was teaching hydraulic excavator, I showed you one that could hold 63 tons in one bucket. 63 tons in one bucket. That was a giant, of course. That's not what that's not very common. So special round bottom hoe buckets. I'm doubting that number, 63 tons. No, that would be a lot. It's 6 tons was 63 tons was the weight of the machine. Okay, yeah, but the bucket size of a hydraulic excavator could be really huge. Okay, but in case of a backhoe, it's a lot smaller. Special roundup hoe bucket is this. As you can see, it's why we call it round bottom hoe bucket. Okay, so the idea is that to make when it penetrates into the soil, it makes it easier for the bucket to rotate in the soil after penetration. So this slide is about how we can calculate the hoe production. Hoe and shovel production are pretty much the same. So we have talked about front shovels, and there will be one question in the homework about it. And so hoe cycle times are approximately 20% longer in duration when they are compared with a similar size shovel. It means shovels are quicker machines. Okay, this machine's cycle time is longer. So optimum depth of cut is important. Optimum depth of cut for a hoe will depend on the type of the material and the bucket size. So you cannot say a fixed range for all the materials or all buckets. The optimum depth is when you can have the maximum, is where you can have the maximum productivity of the machine. Okay, so that optimum depth is dependent on 2 factors, one being the type of the materials and 2 being the bucket size. But as a rule of thumb, the optimum depth of cut or hoe ranges between 40 to 60% of the machine's maximum digging depth. So for each machine, for different types of soil and different types of buckets, you could tell the maximum digging depth. What is the maximum depth it can reach? Okay. Between 40 to 60% of the maximum depth is where you call optimum depth. It means at that depth, you can have high productivity. Why this is important? Because the operator should try to look to situate the machine in a way that it stays between 40% to 60% of the maximum digging depth, if possible. So we have a table that shows the cycle times for different operations. So you're talking about loading, okay? You're talking about swinging after swinging the loaded. So you load, you need to swing, you need to dump, and then you need to swing back or come back, and then the summation of all of this will give you the total cycle time. That is highly dependent on the bucket size. That's why if you have the bucket size, it can tell you the total cycle time in in one cycle, of course. So the production formula is familiar. You have seen this before for front shovels. So this is to convert. This is for conversion because there are 3,600 seconds in an hour. What was Q? Q is the hipped bucket capacity in loose cubic yard. F is the fill factor, means what percentage of the bucket could be filled. And T is the cycle time, okay, that comes from this table. And E is the efficiency, like how many minutes in an hour the machine is working efficiently. Is it 45 or is it 55? And if you need to change loose cubic yard to bank cubic yard or vice versa, there is a volume correction, okay? If you need to convert loose to bank, you will use this. The percent of swell is here. If you need to do loose volumes, okay, if you need to actually, yeah, for the other way, uh, when it is given in loose, if you divide it by 2000, then you can have it in bank, okay. Um, so let's solve one problem and then we are done with this part of the lecture. A crawler hoe having this size, 3.5 cubic yard bucket. Why this is important for us? I will tell you in a little bit. It's being considered for use on a project excavate very hard clay. Why this one is important for us? Because how much you can fill the bucket will depend on the type of the material, okay? So this is the size of the bucket, but we also need to know how much of it could be filled. That comes from a table. That table is table 9.4. To use that, you should know the type of materials. The type of materials is given as hard clay, okay, very hard clay. So you could fill this bucket between 80 to 90% of its capacity. We could use the average of 85% for the fill factor, because if you remember the formula, fill factor was one of the things we need to use. So far we have one element of the formula, which is 85%. So what are the cycle elements? So to know the cycle element times, we need to first know the optimum depth of cut, okay? Actually, we need to know how deep we are digging. According to the problem, soil boring information indicates that below 8 feet, the material changes to an unacceptable silt. So the maximum depth of digging is 8 feet, okay? This is the maximum depth of digging. So optimum depth of digging is 30 to 60% of the maximum digging depth. Okay, but what is the digging depth for this machine? You should take a look at table 9.3. In table 9.3, you need to know the size of the bucket. Okay, that's why the size of the bucket was given to us. So the size of the bucket in this problem is 3.5, but you also need to know the maximum digging. So, I mean, based on that, it will tell you the stick length, which we don't really need in this problem, but it also tells us the maximum reach ground level. Okay, so for 3.5, the maximum digging depth will be 23 to 27. Okay, so what we need to do is that we need to check if the depth we are digging falls into this range. Okay, falls into the range of between 30 to 60% of the maximum digging depth. Okay, so the range is between 23 to 27. You should check if 8 out of 23 fall is actually greater than 30%. Then the information, then you could use these tables, okay? You need to make sure. This is just actually a checking step. So once again, before you go to the next step, you should make sure that you could use the next table. In order to make sure that you could use the next table, the range of digging should be between 30 to 60% of the maximum digging depth. Okay, so the maximum digging range is 23 to 27, and we know that we are digging in 8 feet. We should check if 8 feet falls into the range of 30% to 60% of the 22 of this range. Okay, you should check if 8 feet falls into between 30% to 60% of this range. Okay, so to do that, you once divide 8 by the starting number, which is 23. It is above 30%, so you're good. And you also should check the larger, you should check the end range, which is 27. You are still within the range of 30 to 60% of the maximum depth. That's why, that shows you that the cycle time numbers given by the next table are valid to be used. Okay, so this is just a checking point. You don't actually need it in the to answer this problem, but you need to make sure that the tables are valid. That's why we're doing it. So therefore, under average conditions for this bucket, cycle times could be given or could be taken from table 9.5. So according to table 9.5, it just gives you the cycle time based on the size of the bucket. Okay, so again, I want to make sure you guys got the point. To use this table, you should check that the depth you are digging falls in the range of 30 to 6% of the maximum digging depth. Okay, once you made sure about it, then you're good to go. You can go ahead and use table 9. To use table 9, the only information you put as you use as input is the size of the bucket. The size of the bucket here is 3.5 cubic yard. So for 3.5 cubic yard, it tells you that the cycle time is 22 seconds. It actually tells you that it takes 7 seconds to load, 6 seconds to swing, 4 seconds to dump, and 5 seconds to return. Gives us a total of 22 seconds, okay, is the cycle time. That's another element of the equation, okay? So we now have the cycle time. We also need to find the efficiency. According to the problem, it says 50 minutes of an hour it is working efficiently. So 50 out of 60 is the efficiency factor. And to convert it because it is asking what is the estimated production of hoe in cubic yard bank measurement. Obviously, when you excavate the soil, you're talking about loose soil. So we want to know the bank measurement. That's why we need the swell factor. Swell factor could be taken from the table in chapter 4, okay? Because you remember the chapter we talked about soil and the swell factor. For dry clay, the swell factor is 35%. It's actually pretty high, okay? That's why you will be using 35. Now, what will be the production? The production is now you use the big formula, okay? This was part of the formula. 3.5 is the size of the bucket. 85% is the fill factor, which was taken from here. The cycle time was taken in seconds from table 9.5. But remember, before that, you need to make sure that you can use table 9.5. The efficiency is 50 out of 60, which was given that the machine is working 50 minutes an hour. And since we are converting loose cubic yard to bank cubic yard, you need to put the swell factor here. The answer is 300 bank cubic yard per hour. What is it telling us? It is telling us that this hoe can process 300 bank cubic yard of earth in every hour. And in order to get that, we had to know the size of the bucket, the fill factor of the bucket, the cycle time of the machine, and how many minutes per hour we're working effectively or efficiently, okay? Knowing all of that, we could find the production of the machine, okay? Yeah, so optimum depth of cut is 30 to 60% of the maximum digging depth, okay? So here we are digging 8 feet and we need to check if we are in this range. So 8 out of 23, 8 out of 27. All right, so let me see, I have a few more minutes to teach the loader. Yeah, loader is easy. Doesn't have a lot of elements. So loaders, versatile piece of equipment designed to excavate at or above wheel or track level. It could work in tough condition. You can see even indoors. Oops, sorry. Okay, what happened? They're most effective for non-cohesive materials. Their penetration force is less than a shovel or a hoe. All right, so loaders could come in different types of buckets. The general purpose bucket looks like this. Then we have the multi-purpose. Sometimes they call it 4-in-1 because it could do different types of operations for us. Okay. We have the rock blade. Okay. If you can see, this is how it looks like. It's a V-shaped cutting edge. Okay. And we have the side dump, which you might not have seen before. So I have a video for side dump. And also I have a video for forklift. Let's take a look at side dump first.
Truck or trench and dump the bucket sideways hydraulically and eliminate excess loader travel and lost time.
Yes, so it eliminates longer travel because it can just do it sidewise. So how about the forklift? Forklifts, forklift loaders.
Yan yung gamit ko guys. No? Yan. Nasa rig.
So you got the point, right? So these are forklift loaders. How about changing the bucket? How can we change the bucket? Does the operator need to get off the machine? No. Just dismantle it or detach it. Obviously, it needs some skill to actually put it at the exact right spot. But if you have that skill, you don't have to even need a helper sometimes, someone who tells you what to do, okay? So to find a production of a loader, you need to use different tables. Actually, up to 6 tables are used in that. The production rate of a wheel loader. Obviously, the cycle time is important, but the good thing is that they have fixed cycle times. It means we know that for this type of buckets, the cycle time will be, for example, 20 seconds or 25 seconds, okay? Now, let's solve one problem and then we're good to go. A 4 cubic yard wheel loader, so this is the size of the bucket. It's pretty much similar to what we did a few minutes ago. The bucket fill factor is also important. So for uniform aggregate, which is the type of soil we use here, and you should also look at, the maximum size of 1, and this much. This is the size of the aggregates. Okay, so for this size of the aggregates, and this class of materials, the cycle time would range between 85 to, the load factor will range between 85 to 90% of the bucket volume. So another interesting thing is that you should conservative estimate. To have the conservative estimate, you could use the lower range, 85%. So in the exam, just to have a consistent answer, just go with the lower range of the field factor. So we could have a conservative estimate. We should also check tipping. In order to check tipping, you should look at the load weight, okay? Because if it is too heavy, then there is a chance of tipping. So the bucket size was 4 cubic yard and 85% of that could be filled, which gives us 3.4 loose cubic yard. And we know that the unit weight of this soil is 3,100 pounds per cubic yard. So each bucket could weigh up to almost 10,500 pounds, okay? We should check if this is okay. From table 9.8, the static tipping load at full turn is 25,000, okay? So in 25,000, it is the tipping load. It means that you cannot go further than this. Operating load is 50% of this, okay? You should make sure that your number, the weight of the load does not exceed half of the maximum possible. The maximum possible was 25,000, half of it is 12,500. So, but we know the weight of the bucket in worst case scenario, not in worst case scenario, actually in a conservative scenario, is this much. So we fall within the range and we are okay. So this is just a check. You don't use this information to solve the problem. So typical fixed cycle times are used, and we use table 9.10. It comes from the loader size, the heaped bucket capacity. Since it's for cubic yards, so it falls into the second category, second row, and we're talking about the wheel loader, not a track loader. So the answer is between 30 to 33 seconds. It's also given to us that the machine is working 50 minutes an hour effectively, and the class of materials is aggregates. So now we have all the information needed to solve this problem. You put 3600 comes from the formula, 4 is the size of the bucket, 85% is the fill factor. This is the cycle time that we took from here. Again, we were conservative and we selected the lower range. You could also use the average range. So the average number. So this is the efficiency, 50 minutes out of 60. And this is to convert loose, this is to convert to bank cubic yard. Okay. Estimate the loader production rate. Yes. Okay. To convert loose to bank. So yeah, that's it. And I'm sure you can figure it out, especially if you use the transitions. It will tell you step by step. But let me know right now if you have any questions or if you want me to re-explain it. I can have a quick review. So first, look at the fill factor. The fill factor comes from table 9.6. You should look at the type of the class of materials and the size of the materials in that class. And to be conservative, you could select the lower number, okay, the starting number of the range, which is 85%. This is the fill factor. We need to use it in the equation, okay? We need to check that the bucket will not tip. Half of the maximum tipping limit, if we are less than half of it, then we're good to go. So we need to know the weight of the bucket. The weight of the bucket comes from the type of the material and how much material you can fit in it. The size of the bucket is 4 cubic yard, 85% of that could be filled. So 3 and a 3.5 loose cubic yard of soil could be filled. But what is the unit weight of this type of material? It's 3,100 pound per cubic yard. So every bucket, regardless of the bucket itself, the material in the bucket could weigh 10,500 pounds. To get the maximum range possible, you need to use table 9.8. Look at the size of the bucket, look at the static tipping load, and this number, half of this number will give you the maximum range. This number is 25,000, half of it will be 12,500. Since the weight of the materials in the bucket is 10,500, we fall in this range and we are good to go. The cycle time comes from another table 9.10. In order to use that, you should first consider if you're talking about a wheel loader or a track loader. Also, you need to check the bucket size. The bucket size is 4 cubic yard. That's why the second row is the row you're going to look at. So it will be between 30 to 33 seconds. To be conservative, you could select the lower number. Actually, to be conservative, you should select the larger number. Okay, you should consider that it takes a longer time. But since I use the conservative lower range here, I use the optimistic number of 30 seconds. It means I consider that I could do it in less time than, not 33 seconds. I consider the cycle time to be 30 seconds. Any number in this range is acceptable, okay? Because we are actually just doing an estimate, okay? Efficiency factor depends on the efficient minutes per an hour, so which is 15 minutes. Now you have everything except the conversion part. For conversion, you need to know, you need to know the type of the soil, and then you can convert it. So you put everything you have in this equation. This machine is able to process 527 tons of soil in 1 hour. All right, so let's go to Kahoot, and you should be able to leave on time. Need 57 people. Seven more. 6 more. All right, let's get started. Which one is false about hose? Awesome. Most of you answered correctly. Yeah, they are less appropriate when actually the extended range is required. So we are comparing a hydraulic excavator and a backhoe. Yeah, hydraulic excavators can rotate a wider range. The entire cabin could rotate, not the backhoe. Yeah, the softer is the soil, the higher is the bucket fill factor. Is it right or wrong? That is true. Yeah. The last question. Easy one. That is true. Fixed cycle times could be used. Yeah. So the third player is Christian. Megan, good job. The winner is Blake. Good job, everyone. Have a nice weekend. It's exactly 9 o'clock. I'll see you on Monday. Take care.